In this lesson, I will explain to you rules for division of exponentials and two rules for division of exponentials we will discuss. Before going to start, suppose if I say that A, B, M and N are whole numbers, right? Suppose these are whole numbers. While M and N, they represent the exponents or powers. And this M means this exponent or power is greater than or equal to. This sign represents greater than, and if I put a line under it, so it says greater than or equal to N. And N is greater than 0, right? Then, and also B is not equal to 0, then A divided by B we can define in two ways. First is B M divided by B N, right? And the second is A M divided by B M. So this we can write down B M minus 1, and this we can write down A B over M. So you can say these are the two rules or these are the two theorems related to division of exponentials. So here I said A and B. These are the bases. M and N. These are the bases and these are the exponents. See, B exponent M or B exponent N or power N. While this M is greater than equal to N means these two powers may be equal. Suppose if it is the B square, this is also a B square, or this is B cube and this is a square. So M may be greater than or equal to N, or N is greater than 0. Because I told you, right, if we will write down the power of anything, suppose we have 10,000 and the power or exponent is 0, it will be equal to 1. If we will make the exponent of B 0, so it will be always equal to 1. That is why it says N is greater than 0. Right? And this also, it should also be greater than 0, and B is not equal to 0. Because if we divide something with 0, we cannot solve the problem. So B over Mn. Now I will explain to you in a very easy way. Suppose here this is B, this is B. If the bases are same, if we have numerator, something in the numerator, something in denominator, and our base same, see, this is base same, this is base same, here is M, this is the theorem, and here is N, we can take the exponent of the denominator of the same base to the numerator, so the sign will change, it will be M minus N, right? And sorry, this is also N, it should be N, B minus N. Here I will give you the example. This is the whole number. Suppose if we have 5 cube and in the denominator we have 5 square. See, bases are same, both bases are same. If we have the same base, we can just take the exponent to the numerator, so it will be 5 cube, and this is positive 2. When we will take it to the numerator, it will be negative 2, sign will change, 3 minus 2, which is equal to 5 raised to power 1, or you can say only 5. This is the first theorem, right? It says if A and B, these are the bases, M and N are the exponents, these are the whole numbers, M is greater than or equal to N. So here is M, see, this exponent is greater than N, it is 3 and 2. Now we will suppose if I will take 3 exponent 4 And here same thing, 3 exponent 4, because it says greater than or equal to m. So now is m equal to n, but we have the same base. So how we will solve it? We will just take the exponent from the denominator to the numerator, and the sign will change. It is positive 4, it will be negative 4. 4 minus 4, which is equal to 3 raised to power 0. And I told you the exponent of any number, anything, 0, which is equal to 1. So we will solve the few more questions in the next lesson related to these rules of division of exponential. Then our concept will be more clear. And the second theorem is, if we have the different bases but same power. See, different bases. If we have 5 square here, here we have 4 square. See, different base. Here we have 5, here we have 4. But the exponents are same. So we can write down 5 over 4 whole exponent 2, because this exponent now belongs to 5 and this belongs to 4 as well. I will write down again, it will be same. So if we have a different basis, see here I will round down. Here if we have a different basis, suppose it is 6 cube, right? And here we have 4 cube. Different bases, so we will write down 6 over 4 whole divided by 3. We cannot take this exponent to the numerator because the bases are different. If we have a same basis, right, 6 raised to power 4 and 6 raised to power 2, same basis. So how we will solve it? 4 will remain the same. We will take this exponent in the numerator and the sign will change, which is equal to 4 minus 2, 6 square. 6 square means 36. If we have same basis. If we have a different base, write down whatever is in the numerator, write down whatever you have in the denominator, and make the whole cube or square or fourth, whatever the exponent. So these are the two rules related to the division of exponentials. If any point again is not clear, you can write down in the comment section. But please subscribe to my channel, Saima Academy, and thanks for watching.